If you look at the privacy aspects, we are actually able to identify different vehicles on the road by their radio signatures, including things like RFID chips within the tires, which have been in vehicles since around 2002, looking at different Bluetooth and Wi-Fi emissions. So we work with manufacturers to ensure that their vehicles are secure not only in the physical way, but also in the digital way, and that the driver's privacy is protected. And of course, we're looking at the side channel attacks, meaning that we're able to identify ways that somebody else on the road can control the car's HVAC, heating and cooling system, control the radio, actually control some of the engine components. This is a list of all the all the services that we provide. I'm not going to read out each and every single one, but it's a breakdown by our 4 key focus areas. One important thing I want to point out is with embedded systems, looking at some of the debug interfaces, looking at encryption, not only the key management, the selection of encryption types, but also looking at the implementation. A lot of times we see companies using strong encryption, which is great, but a lot of the vulnerabilities tend to focus around the actual implementation of the encryption algorithms, key management, and key handling. Our typical workflow when we're working with an organization is we first need to identify the needs that the organization may have, to understand how we can help an organization and make sure that it's a right fit, at which point we proceed onto a scoping call where we actually get additional information about the system, and that's used to refine our statement of work and to refine what the final deliverable is going to be. It also makes sure that the testing we conduct complies with any of the regulations that our client may need to be compliant with. At which point we move on to the discovery phase, where we're actually looking at the web application or looking at the device in their test or looking at the vehicle to see if there's anything additional that we discovered which may not have been in scope that we may feel is pertinent that needs to be included. And at that point, if you do discover something, we circle back to the scoping phase with additional questions. Then we move on to the attack and exploitation phase, where we're actually working with the hardware or looking at the application or looking at the network, actually interacting with it, sending packets, maybe actually compromising the application. Then moving on to the post-exploitation activities. If this was an actual attacker working in the application, they would be destroying evidence of their intrusion. There would be exfiltrating sensitive information. In our case, we are just gathering evidence for the report and creating proof that an attacker would be able to do the same thing. And then, of course, the most important phase is the reporting phase, because all the testing is absolutely irrelevant if there is not a complete, accurate, and readable report. We tailor the reports for both the executive level and the engineer level so that somebody at the C level can pick up the report and look at the first 2 or 3 pages and then simply see a snapshot of how their product is doing, what any major deficiencies there are, if any, and the suggested remediation. And there's a detailed breakdown for the engineers that identifies the actual vulnerability, proof that the vulnerability exists, including the packets which were sent and the packets received from the application, relevant screenshots, exploit code, as well as our suggested remediation. And at that point, once we have the initial readout, we provide a report, we let the client digest it, and we have a follow-up meeting to make sure that any questions are answered at that point. Which brings us to the segue of any questions. I'm sorry. Some of the past experience for Spine Security Labs. We have quite a few talented folks on the team. We've worked with a lot of startups. We've worked with some of the smaller independent space launch organizations, drone manufacturers, tier 1s, OEMs. Many of our engineers do hold an active security clearance that enables us to work on government projects. We offer very flexible solutions. We can work remote or we could travel to client sites internationally. We do have 16 offices worldwide. We do have an SSAE 16 SOC 2 data center, as well as a secure portal for the report delivery. We help organizations with PCI compliance, HIPAA compliance, GBLA, MRSA, CERT, and several others. With that, I would like to move on to any questions that anybody may have.
Okay, well, thank you, Vlad. Again, everyone, submit your questions through the Q&A box on the webinar console. We have some already waiting. I'll try to get through to all of them. Again, don't let that discourage you. Please submit questions if you wish. We have one I'm going to ask as a toss-up to both Mike and Vlad, and I'll let you choose who gets it. Question is, can you set up tests to detect attacks from IP addresses owned by China, Canada, or other countries operating businesses residing in the U.S.? Globalization allows companies to set up on American soil.
This is Vlad. So we could certainly set up a test where we can make it appear as if the packets are coming from Chinese IP addresses. We do have data centers located in certain countries. One of the reasons for having data centers there specifically is to be able to simulate tests coming from those locations. So we can make it seem as if the attack is coming from China or several other locations which seem to have a lot of malicious traffic coming from them. For example, if you need to have attack traffic coming from China and Yugoslavia, alternatively, we could certainly accommodate that.
Okay. Got another question here. I'll call it a toss-up. Are you able to test specific ICS industrial control protocol?
Yeah,
so
Mike here.
absolutely.
So, go ahead, Vlad.
Sorry. So we work with a lot of SCADA manufacturers. The most common protocol we see is obviously Modbus, but we have worked with many others. So yeah, so we could work with you depending on the type of control system you have and what you have implemented. The kind of control protocol you have is certainly not a limiting factor.
And I can add to that, we can also, not only can we test specific protocols, like that Vlad mentioned, SCADA, Modbus, and a variety of others, we can test them on, actual load of that particular type of traffic or the messages associated with the ICS type protocols and applications. And when we were talking about protocol fuzzing, ICS is actually a great area where there's a lot of issues or concerns about the robustness and the security of these types of mission critical applications. So at the fuzzing type testing where you're actually breaking apart, say, Modbus or a variety of other ICS protocols into smaller components and using those elements to test at a very granular level what patterns or what messages might cause a breach or some other failure of the end device can be very important to verify the robustness of these implementations and the ultimate security and protection that needs to be put in front of what typically would be, highly sensitive type applications for ICS.
Okay, Vlad, we have a question about car hacking. You were discussing that earlier in the assessments you do. So I'm going to alter this question just a bit and ask you this. How are you keeping up with the challenge of a greater degree of threats that can be posed to cars hacking, vehicle hacking? Just like anything else, the threat is getting greater as the reliance increases. So how are you adjusting for that?
That's a great question. We actually work with the U.S. Department of Transportation, and we work with several car manufacturers and Tier 1 manufacturers to understand the kind of threats that they're seeing. We also speak at numerous security conferences and participate and sponsor the Car Hacking Village at DEF CON and actually a few other conferences. So we're very much engaged with the hacker community as well as with the car manufacturers to understand the changing landscape.
Well, I'm saying, I'm looking at it from this perspective. If I'm a car hacker, I'm going to try to get in where people are not. So where do you think the next biggest vulnerability will be?
So in our opinion, from the research that we've been doing, it is going to be in vehicle-to-vehicle communication. U.S. Congress actually passed laws that states vehicle-to-vehicle communication is going to be mandatory in cars manufactured after 2020. What that means is as you're going down the road, your car is broadcasting certain information to anybody around it. That includes the direction, heading, and speed of the vehicle. And it's supposed to be just those identifiers as well as one unique identifier that's supposed to change every 15 minutes. Right now there's actually only one car on the road starting this year, one production vehicle that has the system implemented, and there's quite a few test vehicles on the road with those test beds. Those systems are supposed to offer complete anonymity because the unique ID changes every 15 minutes. We've actually been able to de-anonymize those vehicles and track them down all the way back to their owners, identify their routes, identify their destinations based on certain radio signatures. So we see a lot of developments around that area, and we see it as a huge attack vector.
Wow. So you're doing your homework before the assignment.
That's our job.
Okay. All right, Mike, let me turn to you. Here's a question. How often are attacks added to your database to keep them up to date?
That's a good question. I mean, as mentioned earlier, attack vectors are always moving, changing, becoming more virulent in many cases, whether it's a new form of a DDoS, distributed denial of service attack, a new exploit that might have been found in a specific device or OS system. These things are always moving and always changing. And what we have is the ability to we have a team that actually updates any of our attack vectors, so whether it's DDoS, malware samples, all our various databases that actually are part of our security offering. So it's updated pretty much on an ongoing basis. As our team discovers these new elements, they're added to our online test cloud services, which is then downloaded automatically or manually in a secure environment to our test devices that are deployed by our customers. So throughout the month, you might be getting updates on an ongoing basis to have the latest and greatest attack structures and attack samples in your database. So we're getting close to 0 day, and in some cases we are 0 day in the attack constructs that we're adding to our databases on an ongoing basis. And this is also true not only for our attacks and other types of content that are associated with the security side, but also on our scale and performance with a database of over 8,500 different applications covering a wide range of different user types of applications. That's also updated with next generation applications that are beginning to hit, or new versions of Skype or Facebook or a variety of different other items that people are using on an ongoing basis on live networks today.